Alright, so just like with any problem, we're going to draw for ourselves a picture. Here's my hill. My soccer ball's at the top. And what does it tell me? What information do I know?
It's kicked.
Okay, it's kicked.
Oh, we have to draw pictures?
You have to draw a picture every single time. And it tells me that the hill is how tall?
22 meters.
Okay, so that's my dy or my dx?
dy.
dy is 22 meters. Okay, what else does it tell me?
Your dx is 35.
Okay, so my dx value is 35 meters. Okay, what's the question? Determine the initial horizontal velocity. All right, so we've drawn our picture. We're going to come up with our chart. X and Y, VI, VF, A, D, and T. Okay, so again, if you've drawn your picture, we can easily add to our chart. Okay, so what can we add to our chart here? What do we know?
Your dy.
Okay, we know dy is equal to 22 meters. And our d... Uh-oh.
35.
I messed it up.
X is 35.
Okay, so dx is 35 and dy is 22. Okay, that's what we have to start with. So,
Your A.
okay, we know some other information. So do we know the initial velocity in the x direction?
Yes.
What is it?
No, that's our unknown. That's our question. Do we know the initial velocity in the y direction? It is
Yes.
0 meters per second. Do we know final velocity? It doesn't. No. Okay, how about the acceleration in the x direction? 0. It is always 0 because why? What's true? Is there any force or anything else acting on the object after it has been kicked?
Yes.
In the x direction. Not in the x direction. In the y direction, it is
Gravity.
gravity is acting on it, and so our acceleration is 9.8 meters per second squared. Okay? Do we know the time?
No.
No. Okay, so this is where we start. The question is, what is the initial velocity in the x direction? This is what I want to know. So here's the tricky part of these questions. I've drawn the picture, I've identified what I know, but I have to figure out the goal. What's the goal? What do I want to know? I want to know the initial velocity, and so I have to then ask myself, what do I need to know in order to solve for VI? So what else do I need to know?
VF.
Okay, if VI and VF are going to be the same, I have to know time.
Yeah.
Okay, I have to know time. So how can I find the time? Do I have enough information in my X column? No, I do not. So I'm not going to use my X column. Instead, I'm going to use my Y column. And I can use this same equation. D is equal to VI times T plus 1/2 AT squared. Okay, so then I know my distance in the Y direction. This is the important part. Now that I've identified what I need to know, I have to be certain that I use the information from only the Y column because we're talking about what's happening in the Y direction. So I take my 22 meters.
Wait, so right now we're trying to find time.
We're trying to solve for time. What do we know is going to be true of time? Time in the Y and time in the X is equal.
Oh, alright.
Okay, so I can say VI, that's 0 times T, plus 1/2 times negative 9.8 meters per second squared, times T squared. Okay, so this goes away, and I get 22 meters equals, if I multiply 1/2 times 9.8, I get negative 4.9 times T squared. And what would I do next? divide by 4.9. And so then after I divide through by 4.9, I have to do what? Okay, so I'm going to divide by 4.9, divide by 4.9, and I'm going to take the square root. So if I follow with my signs, what happens to my, can I take the square root of a negative number? No. So two things that we know are true. The negative sign indicates what?
The direction.
Direction. So it doesn't matter in this case. And then number two, can time be negative?
No.
Okay, time cannot be negative, so we can eliminate the negative sign and we get t is equal to
2.63.
2.1 seconds. 22 divided by 4.9, and then we take the square root of that, and you should get something close to 2.1. Okay? Are we finished?
No.
So now we can add our time in. We get 2.1 seconds. And now what do we want to know? The end.
Initial velocity.
Okay, so we're going to use the same equation so that we have d is equal to vi times t plus 1/2 at squared. Okay, we're using the same equation because that way you don't have to think about what equation needs to be used. Okay, again, be careful that now we're only going to use the numbers in the x column. So my distance in the x direction is 35. Initial velocity, what I don't know, times 2.1 plus 1/2 times 0 times 2.1 squared. Okay, so this whole section down here becomes 0. Anything times 0 is 0. And now what do? I have 35 meters
Divided by 2.1.
equals v times 2.1 seconds. So I divide both sides by 2.1. And I get an initial velocity of 16.7 meters per second. Okay? So then if I asked you what the final velocity of
Meters
the
per
projectile was in the x direction, what would it be?
16.7.
16.7 meters per second. Okay?
Awesome.
All right, so you have 4 questions to do on your own.